Alright, so we're going to start with thinking about how far do you think the planet Pluto is from the Sun? And I want you to make a guess. You don't really have to write it down on a piece of paper since we're not in class, but just make a guess and keep it in your head. And just to let you know, now that you've made your guess, make sure it's in your head, that Pluto is about 39 times as far from the Sun as Earth is. So that kind of makes you think maybe my guess wasn't so good. I might need to make it a little bit bigger. In actuality, Pluto is about 3,647,000,000 miles from the Sun. And if you notice, that's a pretty big number. So scientists in general study these big numbers all the time. And like me and you, they don't like writing big numbers. When you're even calculating the distance from galaxy to galaxy, like the number that would be in miles would be a whole page, basically. So instead they use something called scientific notation. Scientific notation is a shorter way to write a big, and I don't seem to have it written in here, or small number. And the basic form I have right here. And I know this is really algebraic, but a times 10 to the nth power, where a is a number between 1 and 10. So that means that you can't have a number like 0.9. It has to be between 1 and 10. And when I say to 10, I'm referring to 9.9999999 and so on. Either way, this number right here has to be a single digit before the decimal point, to the left of the decimal point. And then it will always be multiplied times 10, but this nth power will tell you how many times you moved your decimal. And it could be positive or negative depending on whether you moved right or left. And we'll talk about that next. So how to write in scientific notation. We'll start by saying that sometimes scientists have to write really big numbers, which we talked about with our distance to Pluto. Here it is again. And if you notice right now, as you've learned in math, if there's not a decimal point in the number, you just assume it's at the end, and it's kind of followed by an infinite number of zeros. So right now we know the decimal point is at the very end of the number. So what we're going to do is move that decimal to form a number between 1 and 10 to get that single digit to the left of the decimal point. So here's our decimal point, and we're going to move 1, 2, 3, 4, 5, 6, 7, 8, 9. Once you make it to that point between 1 and 10, you're going to make a new decimal point. And once we've created our decimal point, we don't really need these zeros anymore. It's just 3.647. We moved it a total of 9 times to the left. And that forms the number 3.647, which is between 1 and 10. And in scientific notation, that's going to be 3.647 times 10 to the 9th. And this 9th power is positive because we were dealing with an original number that was really big. Which is the reason it's a positive exponent. So that leads us into, well, what about the really small numbers? When scientists make measurements, such as measuring the size of the cell, the number's going to be really, really, really small. So you still need to start with the same process, move the decimal to form a number between 1 and 10. So here's my really, really small number. I'm going to move my decimal point. Right now it is right here. And I made this little block because it's fun. I'm going to move it 1, 2, 3, 4, 5, 6. We've made it to the point where that number is a single digit to the left of the decimal. Draw your new decimal point. And we have the number 1.73. Now this time, because we moved it a total of 6 places to the right, that means our original number is really small, obviously. So when we write it in scientific notation, that exponent is negative because the original number is really small. And that's how you do scientific notation for really big numbers and really small numbers.